So whenever you have this type of an exercise, it needs you to be very, very, very careful. You need to know your theorems. That is it. All right. So on this exercise, you were given complete the statements by filling in the missing words. So in each and every case, there is a word, there's a words or word to be filled there that are missing. All right, so that is it, guys. We're going to see this exercise, but I just want you also to remember that whenever you are dealing with your Euclidean geometry, you can have this condition to prove two lines parallel, show one of the following. This is not part of this exercise, but I just want you to remember this. Alternate angles are equal. All right, remember, if you are dealing with parallel lines, maybe you want to prove that two lines are parallel. You do not know that they are parallel, but there's a certain line that is there that is being drawn. And by that, you remember alternate angles are those that create a Z. So meaning to say, if you see that this angle and this angle are equal, by default, these two lines will be parallel. Or maybe you have seen that this angle again a Z, this angle and this angle are equal. As you can see there, we are formulating a stretched Z, a Z that is just being stretched. So that is what you can have in that situation, or whereby you need to prove that these lines are parallel. Once you see that these two angles are the same, therefore the lines are parallel, you can prove from your co-interior your corresponding angles. All right, 4 points are concyclic if they lie on the same line. If you are given 4 points that lie on the same line, they are called concyclic. All right, so those are some of the things that we're going to talk about in our revisions, but you just have to remember that one. All right, on number 1.1, we are given, all right, we need to fill in a line drawn from the center of a circle perpendicular to the chord. That is your first theorem, if you still remember this. What happens with that if a line is being drawn from the center of a circle perpendicular to the chord? We know that this line, it bisects the chord. All right, so it bisects the chord. So this one is gonna bisect the chord. The line drawn from the center of a circle to a midpoint of the chord. Now it is to the midpoint, like this one. It is to the midpoint. So when it is to the midpoint, what is going to happen? It's perpendicular to the chord. All right? It's perpendicular to that chord. So it's a reverse of what we have on this one. It bisects, so it's at midpoint. So meaning to say it's perpendicular to the chord. So this one is going to be perpendicular to the chord. They are just repeating the same theorem. So it's perpendicular to the chord. Perpendicular to the chord. All right. Then 1.3, let us check 1.3. If PQ is perpendicular bisector of chord AB, then PQ passes through. We are back again to the same thing, guys. PQ, like this, they are saying if PQ is perpendicular bisector of chord AB, so let's say this is our chord AB like this, then PQ is a perpendicular bisector like this. It is a line that is going to bisect this AB. It is a perpendicular bisector. Let's say this is our PQ. So the question is that PQ passes through what? In order for it to be a perpendicular bisector, we saw that in order for this to be a perpendicular bisector, it must pass through the what? The center, a line drawn from the center. Already you have the answers there. They're just repeating your theorem number 1. So it must pass through the center of the circle. So this one must pass through the center of the circle. It must pass through the center of the circle. That is the idea there. All right, the center of the circle. All right, 1.4, we are given that 1.4, if PQ and JK are perpendicular bisectors of any two non-parallel chords on the same circle, then PQ and JK will intersect each other at the center of that circle. All right, sorry. And sorry, so they will intersect each other, and the center of that circle will lie on the other what? Where it is going to lie, it will lie on the other point of intersection, on their point of intersection. So remember, these one, they are perpendicular bisectors, all right, of non-parallel chords. So whenever they do intersect, the circle now at this center of the circle, it will lie on the point of intersection. So it will lie on their point of intersection, on their point of intersection. All right, that is point of intersection. Intersection. So this is what you're going to need in this case. The angle subtended by a chord at the center of the circle is the angle subtended by, remember, if your angle is being subtended, to subtend by a chord is to create. So they are saying the angle subtended by a chord at the center, let's say this is our center, it is drawn to the center of the circle is, all right, so it is going to be what? It is going to be twice the angle at the circumference that it is going to have, as long it is created at the circumference of the circle on the same side, meaning to say this angle here at the center, it is 2 times. If this is x, this is going to be 2x. Remember, that is what we talked about, guys, that this angle at the center is twice from our theorem number 3 actually there. So meaning to say here, what are we going to have? All right, this is 1.5. Let us try to have this in writing. So 1.5, they're saying the angle subtended by the chord at the center of the circle is, so it is going to be twice or double. So it is going to be twice or double, like I said, the angle. So it's going to be twice or double the angle subtended. The angle subtended, all right, by the same chord. This one subtended by the same chord. So it is going to be subtended by the same chord. And where is it going to be subtended by the same chord? It is going to be subtended on the circumference of the circle, by the same chord on the circumference of the circle, on the circumference of the circle. All right, the circumference of the circle. All right, on the same side. So this must be on the same side. It must be on the same side. Okay. The angles subtended by the chord on in the same segment of the circle. So this is a repetition. All right, but all right, this one is for the center, but this one it's not. All right, so let us just remove this. All right, so 1.6, now they are saying the angles subtended by the chord in the same segment of the circle. Remember, if you're given a circle like this, then a chord subtends. To subtend is to create angles. So it is creating angles at the circumference of the circle. What is going to happen with these angles that are being created by the same chord in the same segment or on the same side? They are going to be equal. So these angles, they are equal. All right, so they are equal. If this is x, this is going to be x also. That is subtended by the same chord. The angle subtended by a diameter. All right, so this is another part on its own. On 1.7, they need you to know this. The angles subtended by a diameter on the circumference of the circle is always equal to what? This one is always equal to 90 degrees. Remember, guys, a diameter, it subtends an angle of what? Of 90 degrees at the circumference of the circle. If AB is the diameter of the circle, then it follows that ACB is 90 degrees. So it can also be on this side as long as it is created by the diameter. It is going to be at 90 degrees at the circumference of the circle. All right, so that was our question on 1.7. 1.8, they need us now to tell if chords subtend, all right, if a chord subtends a right angle on the circumference of the circle, then the chord is the chord that subtended a diameter, that subtended an angle, this angle that was created by a diameter, it was at 90 degrees, guys. Remember that. Now they are saying the same, it is creating, it subtends a right angle. It creates a right angle. So what type of a chord is that? It's a diameter, guys. This one is just a repetition. So that's a diameter there. All right. Then 1.9, the opposite angles of a cyclic quadrilateral. What happens with opposite angles of a cyclic quadrilateral? They are supplementary. They add up to 90 degrees. Remember, if you're given a cyclic quadrilateral, that is the one that has got 4 vertices on the circumference of a circle. So given this is x and this is y, these are the opposite angles. X plus y is equal to 180 degrees. So 2 angles that add up to 180 degrees. 2 angles, take note, 2 angles which add up to 180 degrees are referred to as supplementary angles. So meaning to say they are supplementary. They add up to 180 degrees. So in this case, we are simply saying they are supplementary. That is the concept there. 1.10, the opposite angles of a quadrilateral are supplementary. All right, if they are supplementary. So this is like this case, what we have here. It was a cyclic. So meaning to say we are simply talking about what then? It's going to be a concyclic quadrilateral. All right. So that one, you refer it as a concyclic quadrilateral. That's a concyclic quadrilateral. All right. 1.11, if line subtends equal angles at points of the same side of itself, then, okay, let's see here. Let's take this one properly. They are saying here, 1.11. All right. If line subtends equal angles at 2 points of the same side of itself, then what's going to happen? All right. A line is just drawn like this. Then this line, it subtends equal angles at 2 points. All right, 2 angles like this. It subtends 2 angles, this one, and also another angle. This is what is happening, this one. And on the same side of itself, on the same side, they are on the same side. Then, all right, so there are 2 concepts that you can consider. If it is like this, if a line is drawn like this, then it means that, remember, we said from our chord, a chord is the same chord can subtend equal angles at the circumference. So if it is like that, the circle is not there. Remember, you are taking like the circle is not there. So it means it's a circle that is what you are creating. Therefore, you are forming what? You are forming a quad. You are forming. It's actually a circle that you're forming. Okay, that is like this. It's like it was never there, like this one. This is the idea there that you're going to put into consideration. So you figure it out like it was never there. It was never there like this. The circle was never there. So if the circle was never there, then it is drawn. All right. You are going to see this way. This one, it is going to be like this. This one must pass through all the points. The one that I drew there, it was going to be something else. So it's going to be like this. All right. So if you draw a circle now, what is happening? You are creating these 4 points on the circle. So if 4 points, because guys, it's a theorem. So this one is like it was never there. The circle was never. You take it like this. This is how you take it. How is it possible that these 2 angles can just be equal? We know it from a theorem that it is a chord. So it's from a circle. They were from a what? They were from a circle. So it's a reverse of our theorems. It's not possible for us to have these angles. Generally, just you have a shape like this. It means there was a circle which was passing there. It was like that. A circle was passing there. So what does it mean? It means the 4 points do not form a cyclic quadrilateral. Is that so? If they are equal, no. They are going to form a cyclic quadrilateral because these 4 points, they are found on the circumference of a circle. So they are cyclic. All right. So guys, be careful. So meaning to say they are cyclic. Then they are cyclic. What does it mean? They form a circle, like they are found on a circle. And these 4 points that we are going to have, they are going to be on the circle, meaning to say we are actually having a cyclic quadrilateral at the end. But the concept is not about a cyclic quadrilateral. It's about having a circle. It's on a circle. It cannot happen generally on any shape. This is what I'm trying to explain. I don't know if it makes sense. I think I tried to go back to those basics that we can understand. But if there is any other way that you think it can be helpful, guys, in the comment section, let's talk about that. Then we can even have another class to talk about this. Anyways, that was the idea there. 1.2, if a line subtends unequal angles at 2 points of the same side of that. All right, so it is just like what we had from the previous case. All right, from the previous case. Then on this one now, this is the 4 points do not form a cyclic quadrilateral. So in this case, it won't be of a cyclic quadrilateral. So the 4 points do not form a cyclic quadrilateral. So this is what you're going to need on this one. Then 1.13, if the exterior angle of a quadrilateral is equal to the interior. So it's, guys, you know, the converse concept. This is what is happening. It's a reverse. So you need to know the theorems first. You need to know your theorems so that you know the reverse of what is happening there. All right. So just revise your theorems 1 or 2. There you're going to understand what exactly is happening here. The exterior angle of a quadrilateral, you just have a quadrilateral like this. Just a quadrilateral like this. Then there is an exterior angle there on that quadrilateral. So they are saying in that case, if the exterior, if it's an assumption. It's an assumption. Let's say if this is happening, like if you see a chord, I mean an exterior angle like this one, if you see it, and this exterior angle is equal to the interior opposite angle. This is the interior angle, this one. This one is the interior. But the interior opposite is this one. Interior opposite. It must be equal to the interior opposite, this one. So if you see this angle X equal to this one, which is the interior opposite, then what is it that is happening there? Is it possible in geometry, in your normal geometry, is it possible? Yes, but it must be on a circle. It must be like this. A circle must be passing through these 4 points like this. And what is going to happen? This is going to be referred to as the exterior angle, and this is the opposite interior angle on a cyclic quadrilateral. Remember the concept of your cyclic quadrilateral concept. So it means these 4 points, they are on the circumference of a circle. And if these 4 points are on the circumference of a quadrilateral, therefore, this quadrilateral is a cyclic quadrilateral. Are we together? Then the quadrilateral, in this case, the quadrilateral is cyclic. So meaning to say, we are simply saying this, therefore, is a cyclic quadrilateral. So to prove that this is a cyclic quadrilateral, it's another way that you can actually use to prove that this is a cyclic quadrilateral. Or you can use this one that we used on 1.10. If you still remember your 1.10, I explained about the issue of a cyclic. This one, if opposite angles of a quadrilateral, there is a quadrilateral, they are no, is it? Yeah, the opposite angles, they are supplementary. We talked about that. Then it's a concyclic, that one. It's a cyclic quadrilateral that we are talking about. Same thing. They can talk about, it's just, what can we say? It's just a reverse of what you are used to on your normal theorems. All right, 1.14, if the exterior angle of a quadrilateral is not equal to the interior opposite, so this time they are not equal. So what does it mean? The cyclic is not, the quadrilateral is not cyclic quadrilateral. So the quadrilateral this time is not cyclic quadrilateral. It can't be a cyclic quadrilateral. It is not. It is not cyclic quadrilateral. That is the case there. It is no longer a cyclic quadrilateral. When they were equal, it was. It's just like this one on number 1.12. That is the case there. All right. Equal chords subtend what? All right, we know this one, equal chords subtend what? Equal angles at the circumference. If there is a chord here, let's say this is chord AB, and this chord is also equal to this chord. On the other hand, here, there's also another chord that is being drawn. And these two chords, they are equal. All right, so let us just say this is C and this is D, E, and F. So if these two chords are equal, AB, if it is equal to DE, what does it mean? It means the angle at C and the angle at F are equal. The angles subtended, or the angles created by these two chords, they are going to be equal. So therefore, in this case, ACB, angle ACB is equal to DFE. These two angles, they are equal. So that is it. So equal chords subtend what? Equal angles. They subtend equal angles on the circumference. They subtend equal angles on the circumference of the circle. On the circumference. That is the idea there. They are going to create equal angles. So if this angle is 50 degrees, this angle also will be a 50-degree angle. So these are the typical questions that you're going to have. Just like maybe in your revisions, it's just useful for you to know this, because it proves that you are actually working with your theorems. So can we revise as much as we can on our theorems, do as many questions just to figure out the theorems, and understand, just even as an individual, just try to draw a sketch to make sure that you understand. If you're talking about the chord, you understand this is a chord, just draw by yourself. All right, do not read theorems. Don't read theorems, but also practice theorems by your own. All right, this is a chord. I draw my angle like this. It subtends an angle. I draw another one. It subtends. Just figure out what is happening. These two angles are equal. Write down your theorems down. Then you cross-check with your textbook. All right, I'm still having a mistake on this part, or this part I'm now perfect. You move on to another part. That is the way that you can actually know your theorems. Do them each by each. So these are the typical questions that you're going to have. Like I said before, we are going to have many questions like this, and also from our question papers from Mason African Motives.